Welcome to the third module of our climate budgeting training course. My name is Olena Zinchuk and I will be your host for today together with my colleague Maria. We represent the Union of the Baltic Cities Sustainable Cities Commission. Today we have an exciting new module, and this is the agenda for it. As usual, we will begin with a short introduction of the project and the training course, especially for some of our new participants who haven't heard it yet. Then we will have an exciting keynote speech about the Danish climate inventory. So that's going to be a big important part of today's meeting, and it will be supported by the presentation on the Aarhus's local portfolio of the climate actions. We will have a short break in the middle to give you a possibility to stretch your legs in between, after which we will still have 3 more case presentations from our partner cities, focusing on the climate action portfolios and emission data inventories from different sectors. So you will hear the presentation from our partners in Östersund in Sweden, in Riga, and in Bytom. By that point of today's module, I will also introduce how we propose to conduct a little matchmaking and twinning experiment at the end of this kind of a joint session. And towards the very end, we allow for approximately 1 hour for the moderated discussions in the groups, but we will mention more about it in the end as well. So last time we had a little bit too little time for it, so hopefully this time we can totally use all the time and dive deeper into many interesting discussion points. But yeah, so this is the outlook of today. You're free to ask questions to the presenters in the chat box. Sometimes we might have time for answering them right away. But if you have like a very specific questions from some of the cases presented, then we can also take them up in the moderated discussions in the breakout rooms. So that's going to be answered as well. So yeah, this is the layout of today. Let's begin now. And the first presentation would be, as I mentioned, a short overview of the project and the total outlook of the training course. Donald, go ahead.
There we go. Thank you, Elena. Thank you very much, and good morning, everyone. Great to see again such a strong interest in this session of the climate forecast training course, and welcome also from my side to Module 3, focusing on the climate actions portfolios and emission data inventories. So my name is Donald Alimi. I'm a researcher at the Hafen City University in Hamburg and coordinator of the Climate Forecast Project. And we are, from the Climate Forecast Project, really happy to have you all here today. This session, like the whole training course, aims to take us a bit behind the scenes of how cities approach climate action and climate budgeting in practice. But before we start, as Elena mentioned, I'll briefly introduce the project behind this course. So Climate Forecast is a 3-year Interreg Baltic Sea region project. At its core is the Climate Action Decision Support Tool, or in short, the CADS tool, an open source tool that helps cities to link climate targets, actions, and budgets into one place. We are a consortium of 10 partners across the Baltic Sea region, 6 cities, together with our tech partner, Causal, the Union of the Baltic Cities with its Sustainable Cities Commission, and then 2 universities, the Uppsala University and the Hafen City University, Hamburg. The key challenge we address in the project is how to turn climate commitments into real implementable action. So cities often face, as we know, they often face limited budgets, capacity constraints, and fragmented decision-making, among other challenges. And climate budgeting can help in this context, but in practice, many cities struggle to apply it. And that's where Climate Forecast comes in. The CADS tool supports climate budgeting implementation, but not only, it can also support other purposes within the climate budgeting world, such as, for example, emissions monitoring, or communicating the cost efficiency of different measures or actions. So overall, our tool allows cities to compare action scenarios and better align planning with the climate goals. And in our 6 pilot cities, we have tested this with real world real measures showing how the CATS tool can support actions prioritization. It can improve how it can improve communication across departments and decision making, and integrate emissions in data into governance processes. And last but not least, most importantly, the tool and the guidelines will be open source from April 2026, so very soon, with that other cities and interested colleagues can explore or even decide to adapt it in their own climate budgeting and governance processes in their cities. So where do we stand today? The project runs from November 2023 to October 2026. So we are in the last year of our project. Next, we have now completed the piloting phase in the 6 cities and are finalizing the tool and the guidelines, as I mentioned in the previous slide. And at the same time, we are focusing now more and more on sharing results, for example, through this training course, which will continue with further modules and conclude with the Climate Budget Summit in autumn. So Olena will explain us in a second. So over to you, Olena.
Thank you, Donald. So yeah, for newcomers especially, but a small refreshment for the seasoned training participants. We have started a training course in the first Climate Budget Summit in Malmo. You can find a lot of materials regarding that in our UBC website and the project website as well. Then we still had the UBC Talks webinar, which repeated the key stances and positions from the first budget summit for people who weren't able to participate in there. And then we continue with the separate modules. Every module has a different registration link for it. So this is something to keep in mind from the practical point of view. But also if you scan this QR code and submit your general interest for the following the course, we will be informing you each time a new registration or a new event has been published. So this is still a very good landing page solution that you can think about. We, of course, try to build the course as a consequent series of different topics. And it goes from a pretty general governance related and organizational issues to much more specific skills and much more specific kind of practices that you might need to require as your own kind of a proficiency in the climate budgeting increases. So this is the overall kind of a layout, and you are welcome to join at any point. So we're admitting participants not exclusively from the beginning, but at any point of this course. And we also try to offer possibilities for deeper exchange and support and joint exercising. I will talk about it closer to the end more. But in general, this is the overall goal that we pursue with this training course, to equip you with enough of knowledge on climate budgeting in general, but also then a little bit more specifically for the tool that the project has developed as well. We will wrap up at the second Climate Budget Summit. At the moment, we plan it to have it back to back with the EU Week of Cities and Regions in Brussels, which would be approximately mid-October. There are dates for it, but we have to submit a bid for the session first to be able to tell you the exact dates, but just something for you to keep in mind. And yeah, we try to make it a very high level and kind of a available event for wider European outreach for this conclude the budget summit, to conclude the course, and also to have a high-level summit at that point. All of the materials will be still compiled now. They are in different event pages and whatnot, but there will be a dedicated training material package which would also bridge the modules one between another, so that you can find your way easier among the topics that might interest you and the subjects you would like to explore deeper. So we have already had the second module in January. It was online. Today we have a third one, and we will be still having online a fourth one on the 7th of May. So please register if you still haven't. The two last modules will be held in person. So we're trying to give an opportunity to also meet and try to get some practical results of the tool application, of discussion with our piloting cities and things like that. And also, of course, the module number 6 / the second climate budget summit will be in-person event as well in October 2026. So this is how we plan to go about the things. For September meeting, we don't have a registration link or agenda yet, but as I mentioned, if you stay in touch with us through this QR code, we will let you know as soon as we have details for that. So a little bit more how we arrived to today's topic, which is climate actions portfolio and the emissions inventory.
Yeah, so with the next couple of slides now, I'll try to briefly frame somehow the module today, bridging, in particular, bridging to the previous two modules. So in the past training course sessions, we presented the concept of climate budgeting and both formal and informal approaches to working with this concept, as well as we also covered or discussed examples of collaborative processes of the climate forecast cities. So which approaches our cities had taken. And now we move more to the operational side of the working with the climate budgeting. So in today's session, we will look at how emissions are actually calculated, both for baselines and for specific measures, with examples from our pilot cities. So here it's important to differentiate between emissions calculations for climate budgeting versus the development of climate action plan or similar climate strategy. So a CAP ideally covers the emissions of the city, baseline and reduction goals over several sectors, for each of which there are specific sectoral goals and measures. And for the purpose of climate budgeting instead, we zoom in on measures, on the measures themselves. And in the process of climate budgeting, the focus is to support specific funding decisions about certain emissions reductions measures, or to improve versions of these measures. For example, to implement something sooner or later, or to implement a greater or fewer units of, for example, PV panels. Yeah, just as a couple of examples. So in practice, it might be wise then to begin from the bottom up. The key question to ask yourself is, which measures are up for consideration or for funding? Or where are the biggest questions about the return on investment? And then the focus on making detailed and specific emissions calculations for these measures in question or the chosen sectors. So that would come next. Therefore, for the climate budgeting, it's important to remember that it's not at first necessary to depict the full climate action plan, and every single measure in an exhaustive detail, but maybe start instead with the key areas that the municipal budget can integrate now, and then in the future add breadth as it's needed, so get wider as it's needed. And with that, I think I would stop here for this introduction to this context, to this framing of this module number 3. And thanks again for joining us today. And back to you, Olena.
Yeah, thank you, Donald. So exactly like Donald mentioned, you will hear much more specific examples from different sectors towards the end of today's training. But in the beginning, we want to talk slightly more on a general level, and we have a keynote presentation about the Danish climate inventory, a municipal collaboration that has been built in Denmark a few years back. I guess we will hear some details on it and how it unites the cities in this quest and how it supports them throughout with some uniform, or if not uniform guidelines, then at least possibility to discuss and negotiate this. So Anders, welcome, and please go ahead with your presentation. I will stop sharing now so you can put your screen on.
Thank you very much. Great. Yeah, I'll be sharing some of the experiences we've had from working with these topics in Denmark. Before I dive too deeply into it, I'm just going to do a very brief introduction to who I am and the company I work for. I'm a principal advisor at Riga and Bytom, and we're a Danish consultancy with offices both in Denmark but also in Brussels and elsewhere in Europe. We work with basically anything sustainability, which is also why this is such a core topic for us. Two of our main things that we focus on is digital solutions, as this is, and climate action plans. So this is at the very core of what we do, which is also why we're happy to share our experiences from this. Personally, I've been part of the climate action plans in Denmark for 4 or 5 years by now, working mostly on the data side of things, getting all of our backend set up because there's a few data points that has to flow through to make this happen. But also recently working on developing our scenario tool for this, being the technical responsible person for that. On the menu today, I have a overview of what Denmark's municipality climate inventory actually is, why it started, the starting point for that, how we build and run it, what value it brings, and also to some extent what we've learned so far, because we do continue to learn doing this. And in the end, I'm also gonna try to get a starting point for where do you guys start if you're on different parts of this path. What's the next step? But in the end, this all starts with questions, and I think you will be sitting with a lot of the same questions, and I imagine a lot more as well. Starting with how much CO2 do we actually emit as a municipality, as a city, as a region, and as was also mentioned before, which sector does it come from? Because one thing is how much we emit, but also focusing our efforts in terms of what matters. And also, how do we coordinate our efforts? Because one thing is you sitting maybe with 1 or 2 colleagues, maybe just on your own, figuring out how to do things. But it's always nice to have this network, which is also really great with this shared European efforts. But how do we coordinate this when we approach it slightly differently? And more recently also, now that we've mapped what the emissions are, how do we work with them? How do we change something? And where do we focus in terms of what delivers the largest reduction over, say, the next 5 or 10 years? And if we had an answer to all this, and in Denmark, we sort of do by now, but if we had that general, you could get a clear number about what you emit, where to focus on. And you also get a simple storyline to explain to politicians, to citizens, and to coworkers. That's kind of when you look at where you're at. But you also get the idea about whether you're moving in the right direction once you start forecasting, once you start tracking where you're headed. And speaking of climate effects, realistically, you also need to adjust our efforts if we're falling behind or if things are changing along the way. And again, always coming back to a prioritized list of what to focus on. I'll come back to the climate budgeting part of things, but also just what are the big parts of this. In Denmark, the ambition was also to have a common basis across all of the Danish municipalities, because the collaboration part of it is just so important. We as consultants, as experts on the outside, can do a lot of things, but in the end, if the people who are working with this every day have a shared language that they can talk together, that's always the better option. For that purpose, we have over quite a lot of years by now, I think it's more than 10 years, developed Denmark's climate inventory, Klimaregnskabet. And this is a climate inventory that covers all of Denmark, all of the 98 different municipalities. And out of those, 95 of them actually use this as their main climate action plan tool. So that's been a road getting to that point, but it also means that we're now at a point where this is basically the standard for climate accounting in Denmark. And if we jump to the online version of it, this is the free to access version of the climate accounting tool. I've just chosen my own municipality. There's a lot of insights in terms of CO2 emissions over the years, renewable energy shares, sectoral insights, and lots of things to dive into. And this is free to access for everyone. For the municipalities, there's a much deeper insight level as well. But there's two sides to this. The process of getting here has taken a while. And I imagine some of you are interested also, how do we get this going, depending on where you're at in the process. Initially, this was a state partnership with regions, with municipalities, and with private NGO kind of setups with Dania that aligned on a shared vision for climate data and saying, we could do this better, we can do something that's more consistent across things. So they set out together to develop a shared methodology. There's been some ongoing platform development to kind of frame this, to bring together the data sources, and to figure out how do we share this knowledge as well once we've had it. Over the years, there's also been stepwise iterative municipal adoption. I'll dive way more into the process behind that, but it's been step by step, as was also mentioned before. This does not happen overnight. This is a long and continuous process, which also means that we're still working collectively with the municipalities to refine the methodology, to get better data, and to just expand service features and keep the ongoing support running as well. So this is all one big collaboration, and we've built it from the scratch, but it's been a lot of iterative processes getting to where we're at today. At the very core of all this is the fact that the users own the tool. In this case, it's the municipalities. They also own the process and they own the decisions. We as consultants, as technical experts in this, we build what's asked by the users. So at any point in time, there's obviously some processes of getting all this together, but at any point in time, we do not decide the main directions of where this is headed. This is built from a user need first. And if we dive into the practicalities around it, how it actually looks, the technical side of things is that we collect and process the raw data. And we have, last I checked, about 80 different raw data sources. And that is everything from transportation surveys into how many people in this region drive electric vehicles or bikes or walk, all that kind of things. But also energy production data at a very detailed level. Every single energy production unit in Denmark of a significant size, but like any specific industry production unit, is going to be mapped here. If it produces electricity, if it produces heat, that may or may not be shared outside of the premise. So it's a massive data set for that. It also contains a list of how many horses do we have in Denmark on a national level, which is then disaggregated. So it's also coming back to what's the width of the data being fed into this. I see those 3 data points as being slightly different, but we're collecting all of them. And practical side of things, we're collecting all of them into a Power Query thing that pulls all of this into one main data source. So some of my good coworkers, they pre-process all of the data, so everything is kind of funneled into the same setup, and we pile all of it together, feed it to a core climate accounting model, so a climate inventory model, that then splits and say this part of the data is relevant to this municipality, and so on. So we can create municipal level versions of each model, but we can also actually do specific regional settings of it. Say we want these 4 municipalities together to examine what's the climate inventory looking at that stage. Once data has been processed and being fed into this model, we now have a model that shows a detailed breakdown of energy and emissions. Some sectors are extremely detailed. We have individual ferry routes. We have individual wastewater handling units that are modeled into this. So there is very high levels of details in this. Some of them are extremely interesting. Some of them are not as important, but are still there. So we have the data, we're going to include it. You can start much leaner, but this is kind of the level of detail that we've at. So this is the technical side of things. We collect the data, process it, and feed it so the municipalities don't have to do this individually. Because let's just be clear, this is a time-consuming experience. This is a lot of what we do each year, collect the new data. So there's a lot of time being spent on this part. One thing is data, though. Figuring out what to do with the data is probably the hardest thing. You can grab data, you can get poor data, you can get good data, but in the end, the main value lies in the fact that you can agree on how to treat it. We apply the methodology when we do the data processing. Some of it in the pre-processing, some of it applied in the core model where users can see it more directly. But all of the underlying methodology is in essence decided by user representatives. So we can do some minor adjustments, but all of the main decisions, like having a new way of calculating emissions or emission uptake by forests, that's a core decision that has to be made from the user perspective first. And this again comes back to every new feature starts from the users. So whenever a MES or someone else has used this tool for a while, they figure out, could we do something different? Could we add something? Could we change something? That's what drives the development. And again, one thing is having the idea, then everything is taken up at a representative level, saying, can we then decide on how we will do this so it covers everyone? Because even though Denmark is a really small country, there are differences between the regions. And it is a balance between figuring out there's more city dense municipalities. How do we balance their needs with the needs of the ones where agriculture plays a much larger role? And there is an ongoing debate about how to balance those things. A core aspect of why this works is the organizational setup around it. Because there's a few different layers to it. Obviously, we as technical experts, we are at the everyday level of this, working in terms of having some support to the users. But we've been the technical experts throughout the years on at least most of the projects in this scope. And we've been continuously part of deciding how to actually build things. But a core unit in the organizational setup is a steering committee that decides, is this a good change? Is this a bad change? Do we need some more broad interaction with all of the users, all of the municipalities? Or can we decide as representatives as ways to change things? So all of the main methodological decisions are done by the steering committee or at a broader municipal level. They are also responsible for the economic and developmental prioritizations. The process is that we get some input from communal working days, so everyone has the chance to bring something forward. We then comment and evaluate how much work would this take to implement this change. And then in the end, the steering committee prioritizes where do we put our efforts? Because as mentioned earlier, they own this tool, they own this project, which is a core thing. We need someone that has the ownership at the right level to guide the decisions. The communal working days are actually a core part of this as well, because we get these shared inputs. We also have the options of doing some presentations on the changes we've made. We get some very lively discussions when we've changed something that now makes some municipalities, their climate inventory rocket, and others go down. And this is always there's a difference between how happy people are about these changes. But again, this is also why it has to come back to a user-driven change. We get some very open dialogue regarding the development and the changes we have made, which is really healthy for a thing like this, because it's only as long as you have this shared acceptance of this being not the right version, but the least bad version, because all of these models are going to have parts that you do not agree on, something that you do not like as much, but it's going to be the best way for you to do the climate inventory, to do your climate accountings. When you reach that point, that you agree on that, that's much, much stronger foundation. Day-to-day operations, municipalities can use this as their main tool for evaluating emissions. So when Mass or someone else is working with what's the emissions from the waste sector in our municipality, they can use this as a way of evaluating that. And they will be using it the same as the next municipality and the next one. Even though we believe we've made a really good model, there's always their need for user support as well. So that's also our part of the role. So we are in a ongoing continuous user support role. So it's every user has the option of writing and asking us questions on a mail service, so we can kind of support usually quite small, like why is this number different to this one, explaining either the tool side of things or the methodology side of things that's behind that change. One thing is being able to model and calculate and stuff. This is now also the core tool for political decisions around climate in Danish municipalities. And that's actually something we're really proud of. This is actually so well established that it's now a strong tool for the municipal workers to bring to their politicians saying, this is what the change will be. This is where we're at. And now also with the scenario tool, this is where we'll be if we do these things. Each year, we are fed a yearly development plan, as said before, based on user input, qualified bars, and selected by the steering committee. So there is a yearly process of how do we bring in the next bit, because we've developed each and every year since we started. It did not start out this detailed. It's a much different starting point. But even when we're not doing the user support, there's also this shared language that brings all of the municipalities together so they have a shared foundation for all of this. So to recap in terms of what we learned looking at the climate inventory, it's really important to have this methodological ownership. There has been a history of having two main different approaches, both of them good. The idea is not that there's one methodology that's better than the other, but having the ownership anchored for the region that you want to target is key. So having these shared standards, there's less duplication, and you have increased trust. So there's no, but what if we use the other method? Would this look different? This is the way. And that's why you should start with the ownership and not with data. And as much as I like to think that the experts are crucial, we're here to support user needs when we do the organizational setup right. Has to start from the user. In terms of the technical side of things, scope and geography is really important. So figuring out what is included and what is not. That's probably easier than the organizational setup, but it's still important to cover that. The data collection is very labor intense. So if you can get to the point of having a common logic, there's so much to be won by having one point of entry for all of the data, having one expert group or similar be in charge of the data collection, doing the pre-processing all according to a common logic standard. And now I've talked a lot about how the data that we process is a lot of bottom up. That's something we've developed over the years. So when we have the bottom up data, it's usually worthwhile to include it, but also prioritize based on where that's value. But a lot of time top down is also sufficient and efficient. I've mentioned the horses, one example. We have one number of total horses in Denmark per year. That's it. So we have every single energy producing unit and one number for horses, because they do not matter equally much in this case. So top down, where that is sufficient and efficient, is the way to go. So there is a continuous balance between whether you do the bottom up detail approach, whether you do the top down good enough approach. And usually when you start, there's going to be a lot more top down, but that also allows you to figure out where to prioritize and building up the bottom up model. And transparency across all of this, knowing where data comes from, knowing what is being done with it, seeing what the model actually calculates, is actually more important than technical complexity. Building something that's slightly more wrong, but clear, is usually a better option, even though it hurts my technical soul. Being an engineer by background, this is a hard line to write, but it's true. It's way more important that people know what's going on and understand the steps along the way. There are some other demands for what constitutes a good climate accounting, good climate inventory, is that you must build it to support recurring updates. Every time you have this option saying, but we can just do this, so it's just going to be now we'll just fix the problem now. It's usually not bad. It's usually a bad thing. Again, coming back to both transparency and whether you do the bottom up or top down, it's better to have a stable top down approach than to have a one-off bottom up thing. If you do it as a testing point of figuring out how do you do the bottom up, that's a different thing, but focus on having the stability of it at the very core. I've covered the users quite a lot, but it's also why it's so important to be both involved in operations and development. And having this annual planning that prioritizes, because at an annual level, you can sort of forecast the workload, but you also have some openness to bring together all of these technical improvements, governance decisions, and user priorities, because there is a balance to be struck between all of these dimensions. And you need someone that has the core ownership of making those decisions in a mandate that's been supported by all of the users of the tool. But that's just Denmark. We've actually gone slightly further than that as well in a different scope, different project with the Global Covenant of Mayors, where we've been part of creating data portal for cities. Again, coming back to how much bottom up, how much top down, this is in essence largely a top down application focusing on specific countries around the world. But this is one way of taking what we've learned in Denmark to a global context, actually. Because the road here is long, and we've tried to make it slightly shorter for those starting out now. This allows nations to dive into and start working with their climate inventories without having to go through those 10 years of development before you have something that's somewhat useful. And if we look at Brazil, which is one of the most recent countries we focused on, they had this chance of saying, we want to do something, but where do we start? So there is now a national generation data set. So on a governmental level for 5,000 Brazilian cities, that is national data that's being descaled based on some methodology. This means that we have some local distribution in terms of having each of these cities having a local city climate account. But that's one thing that we can have the top-down approach, which is going to be inaccurate. But it also means that the cities have the option of enhancing their inventories. They can bring in supplementary data. There's a whole framework in terms of you can change things, you can add things, because we're not going to cover everything, at least not on the first point. But there is an option of continuing this work in the platform that way. And as much with everything, one thing is data, one thing is platforms, but knowing how to use this platform, knowing how to use your tools. We've also covered some online courses in terms of their climate practitioners, much similar to many of the positions that you guys are in. How do you use this? How do you work with this? Is also a big part of it. So this is how we went from a Danish scale to a Brazilian scale. The Brazilian climate inventories are vastly different to the Danish ones. But it's also about how do we get things moving, how do we take the first steps. This is why the data portal for cities, that's what that platform is aimed at. You could, in essence, bring in whichever modeling approach underneath the data platform that you want to. You can host it anywhere else as you do in the Danish setup, but just to give you an idea about different approaches of addressing climate accounting at a regional level. In the case of data portal, there is national level management capabilities, also some more local setup, so you can log in and have your city being represented in and control the input. You can do the adjustments based on the general top-down climate account. And you can scale this. So if you figure out that now we have the first top-down version, we now figure out which two sectors do we focus on. Because realistically speaking, you're going to be strapped for resources throughout this. So it's a lot about figuring out where to spend your time, where to spend your money before it runs out, and you need something that's actually useful in the end. So generally, we try to build to different contexts that can scale in the end, because we know that once you finish one project, you're at a point where there's a million different ways you can continue building. See where we're at on time. I think we're going to skip the questions now. We might bring them back later, because that's all about climate accounts. So in essence, where are we at? What did we already emit? But what if we move into the future? Because one thing is measuring what has already happened. To me personally, way more fun, but also because it's way more challenging, is where we headed. Because most places we need to change things to be headed in a good direction. So this is some of our most recent work, is actually a scenario tool building upon the climate account to shape the path forward. As soon as you move into the future, you add uncertainty, but you also add some freedom to answer approximations. But in the end, you're going to have users from vastly different backgrounds that has to bridge the gap between. We need someone with less technical skills and very deep technical skills to be able to use a shared foundation of looking a lot of years into the future and figuring out what happens. So we've built a quite detailed sectoral scenario tool. So we're forecasting emissions and energy consumptions sector by sector. Not as detailed as the climate account, but in many cases quite close to. Because we're building straight on top of that foundation. This also means that each municipality in Denmark has a business as usual pathway without doing any more work. All of this is based on national projections, lots of different assumptions and constraints, but it's quite a detailed model underneath it that represents if this happens and the municipality doesn't do any more, this is where we're headed for 2050. They now, similar to data portal, have the option of adjusting all of these things, saying that we expect this to happen, not this, if we don't do anything more. Or we expect the national trajectory to work, but not as much. I can show you the tool just briefly. Say the bio-natural gas production, saying that the standard is that nothing happens unless the municipality does something. But we can change that, saying now we have the national expectations of development, but that's a little bit too ambitious. We're just going to do 30% less change than that, which now means that this is all that has to be done for a municipality to have adjusted the national projections to something they believe in, and this is the business as usual. Again, across the core of all of this is the consistency across the municipalities. All of the municipalities will be working with future forecasting in the same way. At the core of all this is one of our design principles that we design for simplicity in the front, basically simplicity for the user, but we need to handle a lot of complexity in the back of the model. So for the bottom bit, this is just a very small snippet of the backend of the model. This is all built in Excel, using modern Excel. So we have some freedoms, but still there's a lot of stuff going on. Coming back to, if you change natural gas production, that's going to impact pretty much every single sector. If you change the way people are driving, you're going to impact the emissions from housing, because the way the methodology is built, you share the energy that's available. So if you change the energy consumption in one sector, it's going to change the energy mix for all of the sectors. So there's a lot of different feedback mechanisms that has to be represented in the back of the model for something that's accurate. But I assure you that most users do not want to think about those things. They just want something that's easy to use. It does represent their world, but again, coming back to, if they want to work with saying, what if we increase the bio-natural gas production by 75% in 2050 and linearly going there? This is now the business usual. If we increase that, you now have the increased values that's being fed into the model, and you now have a larger share of biogas production in your whole system. So something as simple as this, with the option of expanding, and if you want to have the full thing, there's a lot of details to be had, but you don't need to. You can, as a user, work with simplicity, and I'm going to put that in quotation marks because this is not a simple topic, but you can make it as simple as possible and handle all of the complexity in the back end of the model. So this is what we've built upon in terms of the emission side of things, in terms of the energy side of things. This is ongoing work, but it's also where we are seeing a lot of the work in the front line being carried out as well. It's also a really important thing because all of the political decisions, also coming back to how you work with climate budgets and climate budgeting, they need some evaluation in terms of, are we on track? This can provide you the baseline saying, what is on track? What will happen if we don't do anything else? What will happen if we do a lot more? And where are we at in this range? Another thing that we're looking into is actually similar to the core of this European collaboration, is climate budgeting and climate budgets. I added asterisks to climate budgeting right before I went on due to the definition fun of having climate budgeting. There's a lot of different ways of approaching that. One is figuring out, you have this much budget, how do you spend it? Say you have a climate plan, you have a climate action plan, you need to go to a certain level of emissions. How do we get there? That's one way of approaching it. Another is figuring out, with these 8 different budget ideas, what's the CO2 effect of each of them? So there's a few definition things to keep in mind when comparing things here. We're trying to consider both, but also similar to what was suggested previously, focusing on evaluating the effects of specific ideas in the political space. Focusing on creating this link from the emissions to the budget discussions and economic priorities, because if the politicians can consider we need to invest this much money now and over the years, why shouldn't they be able to do similarly with the CO2 emissions? The thing is, though, you add a different scope as well, because the whole of the climate accounting part is focused on scope 1 and 2 emissions. But a lot of the emissions from investing is scope 3, which is different in nature, but also vastly different in the complexity of getting something that's a good data point for this. So there are some challenges there, but we are currently in talks about, should we continue developing based on this shared municipal setup? Because this is the framework we have. We use the same organizational setup around it, but we can create a project space to the side of it. And then, due to the fact that all of our models are built scalable by design, we can continue to add new elements, new layers to this, and also possibly using PETs as a visualization tool for this. I think there's a lot of value in using that tool as a visual overlay. But one thing is visualizing, the other is figuring out what numbers to visualize. And even more importantly, figuring out a way to get to those numbers consistently so it's the same for each user across the tool. So that's a lot of words about where we started, where we've headed. But what about you guys? How do you guys start? And I imagine you are at vastly different points in this process. But just to go through all the different steps, at the very core of this is to define partners and a shared ambition. Similar to how the Danish process started, figuring out a group that can collaborate on this and figuring out the right level of ambition as well, because starting small and then building is the way to go. Figuring out a way to organize the project, getting that governance structure in place, and evaluating that for the first few years as well. This has changed a lot in the Danish context. We've had the state and other parts starting this, but right now they're not a main part of it. This is owned directly by the municipalities and their representatives. So it can change over the years, but the core is that you need a robust governance structure, and you need to define at least an approach to it from the very get-go. And only then you start developing the data set. And you're going to have some absolutely horrible data at points during that process, and that's fine. With the first iterations, you also get the idea about which sectors take all of it, which are less important, and you focus your efforts on the big bits first. But also keep in mind, you might focus on some of the medium sizes if the data availability is good enough for that. And then you can start to roll out and bring it out and just share that knowledge as soon as you have it, because the feedback that you will get from many different sources is so valuable in terms of doing these iterations, because you're not going to hit the bullseye from the first time around. It needs to have these iterations to get to a really good point. At the very core of this, how to get there. Do not wait for a perfect model. Also because it just doesn't exist. But focus on building a usable one with the right ownership. And then you continue to develop and expand together. This is at the very core. This is how we did it, or we did some of it at least, because focusing on these things could also cut at least a few years of our development time. So even though it's been at the core, this could have been even more strongly enforced. So having the ownership first and then expanding together is the way to go about it. So for our side of things, we continue to improve and expand the Danish model. We're going to add more scenario support. We're going to add more initiatives to assess, to have, again, the simplicity being brought closer to the user. We're going to continue to explore the economic dimension, so bringing it into climate budgets. And no matter how we approach all this, it's going to be a collaboration across all of the different dimensions. We also see that increasing number of countries, regions, cities, all sorts of sizes are looking into using more climate accounting models to support their work, because one thing is focusing on the area, but also bringing in the models to have that consistency. So reach out to whoever you're maybe already collaborating with or could be collaborating with, to figure out, do we share some of the same pain points, and do we also share some of the same ambitions, so you can share that process. And if you want our eyes on your situation or project, we're happy to reach out, just for you to reach out, and we can do a one-on-one session, just seeing how does this translate into your world, because we've accumulated quite a lot of experience about what to do and also what not to do, and are very happy to share this, because this is so much at the core of what we as a company want to do. So we're really happy to support that process across this whole region. Right. That was the points for me. I think we might have time for a question or two, if there are any.
Thank you, Anders. I don't see any in the chat. Oh, there is something appeared. Yeah, please go ahead if you can.
Yeah, I have them here. The question is, how is this municipality inventory related to the national inventory? Is there a relationship despite the different methodologies? It's somewhat related. There is, as you say, a significant gap in methodologies, especially in terms of what the scopes are. We do not consider the national interchanges as much. We consider the municipalities as a regional geographical scope and scope 1, 2 exchanges there, which also means, for example, a district heating network that spans across 2 municipalities. We're going to like bring that share in, and we're going to have that municipality connected to the rest of Denmark as a whole. So it's a slightly different approach there. We use a lot of the data from the national inventory, especially the forecast parts. So each year, the Danish National Energy Agency releases a new klimafremskrivning, a forecast of the climate effects reaching, I think, towards 2050 usually, but to 2035 with good data. So we use all of that, and that's based on the national inventory. So it's mostly flowing down from that. The national inventory also isn't very useful at a municipal level for everyday discussions. So this is more of a translation into what's the real world for municipalities.
Thank you. Please feel free to reach out to Anders the way he advertised in his slides, but also through the chat if you're still staying with us until
I'll be staying for the duration.
Yeah, that sounds great. Thank you.
Thanks.
We move on now to Mads, who has been teased a few times by Anders as well. And we could see how our partner city of Aarhus is working partially with this methodologies provided on the Danish level, and then using the data and the other things in order to pilot the climate actions portfolio for this project that we're part of. So Mats, please share your screen and welcome.
Thank you, Alena. What I want to talk about is how we go from what Anders just presented with emission baseline, emission forecast, to actually using this in our political work with how we actually get projects off and running and show our politicians and stakeholders an actual CO2 number. So when you do this thing, what does that actually impact? And to do this, I'll briefly go back to what Anders talked about with our emission inventory and our business and usual scenario, and actually think about the purpose of these and how we use this into our day-to-day political life in Aarhus municipality. And then I'll say, once we have both this emission inventory and this business as usual, how do we calculate and present results from our calculation models? Well, use quite a lot of time on the presentation and how we get these results actually moving in the political and stakeholder sphere of our work. As Anders said, in Denmark, we have this collaboration where all of us make emission inventories in collaboration. And I would like to also say that the purpose of our emission inventory is not simply to give a CO2 number. That is the main purpose, and the first thing we try to do is to say that the total emissions in Aarhus in 2025 were 1 million tons of CO2 and so on. But when we do this bottom-up approach, we gather all sources of data that can be used all across the municipality for answering different questions. What is the state of forestry? Has the biodiversity been impacted since there's been less forestry? How is the car usage? Do we see an increase in the kilometers ridden by cars? Is that something we have to discuss with the mobility department? Do we see a general decrease in our power generation so that we have to look upon increasing the grid capacity of Aarhus, and so on and so on? All these questions is what's driving the climate work, but it's also a part of our inventory when we do a comprehensive bottom-up approach. And this amount of data and this amount of knowledge is really being appreciated in our municipality, because that means when I go to talk to people who are building roads or building bridges in Aarhus, we are not talking about CO2, that's my department. We're talking about how do we decrease the kilometers ridden by passenger cars and get more people into buses, which is what we really want to be doing. So I can move myself away from CO2 numbers and talk about what's really important in their department. And that's really being enabled by this. As Anders was saying, data is not perfect all around. Sometimes we're just using top up and get a national share of emissions, and that's fine. But it's an ambition to be bottom up, activity based all across, which allows us to have these very good discussions and good projects that are not based upon what CO2 number do we want to change, but what activity do we want to change in society. Anders also talked about that a lot of the purpose in the Danish collaboration right now is upon building a good business as usual model. And to many of my bosses and to many of the stakeholders, the business of usual model seems a bit irrelevant. That's just a number. What is it? But in my perspective, the business of usual model, the number it gives us is not that important. What it really is an imagination of what would happen if we do nothing at all. This would happen. And of course, there's no chance that ever would happen because we want to do something for the climate, and maybe the EU level does something for the climate, or the national level does something for the climate. So the number itself is not that important. The real purpose of creating a comprehensive business as usual is a tool we can use for our calculations. Because when we use this business as usual model at the activity level, so the number of horses, the number of sheep, the different types of electricity generation, that allows me to have the same discussion I was talking about with the emission inventory in the future with the other departments. And then we're back to what we really want to be changing is the activity. We want to increase power generation by renewables. We want to make our energies consume less energy. We want to improve accessibility for buses or electric vehicles, and so forth. A key feature of the business as usual model is also driving our calculations. And the main thing that we believe is driving these calculations is you set up sort of a causal chain. When you do this, it affects something over here. In my language, I come from economies, we call this general equilibriums. So production of electricity has to meet demand for electricity. So if I push one of these, the other one has to react, and so forth. Many fields of expertise call it different things, but just these interaction call to change is the real thing that is going to define how we get a CO2 number. And that is defined in the business as usual model. And this is really, really important, because if I set up a business as usual model assumption that says if Aarhus grows by 10%, we're going to produce all our electricity by coal. The CO2 number by wind turbines would be extremely high. If I say on another day that if we become 10% more people and need 10% more electricity, we would do this by trees and forestry, which in an emission inventory has a CO2 number of 0. The CO2 reduction from wind turbines would be 0. So just setting up this causal change can change a CO2 number from a wind turbine from 0 to 100,000 or 10,000 CO2. And that's why the real important calculation part of CO2 is not within the reduction scenarios, but in the business as usual model. So to say how we've done this, at our current state, in Aarhus and most Danish municipalities, we have a comprehensive emission inventory and a BAU. And then we also have been working with climate for several years, so we know what we want to do. We want to set up wind turbines, we want to set up solar cells, and so forth. And when we do these models, we refer to them as shocks to the model, where we shock the model by saying we increase our let's say, take action 1 as an example. We increase our energy production from wind turbines. That means that we've pushed the general equilibrium between energy production and energy consumption because we increased our production. We've then in Aarhus defined that our part that moves with this model is the amount of electricity we import from other municipalities. We're a quite big city, we can produce all our electricity itself, so we get some from other municipalities. We've then set up this causal change that says we have to import less. This could be discussed, but that's how we've set up it. When we then lower our imported electricity from other municipalities, emissions are expected to fall by something. Another example could be that in order to both be greener and get more areas in our city, we restrict the mobility of passenger cars, mostly fossil passenger cars. This could be by narrowing the roads or having a fossil-free area in the middle of the city. This reduces your own tendency to take a car as a commuter. This could be taking the car to work, taking the car shopping, etc., etc. We've then defined several common transportation modes. Like if you live far from the city, you use your car more. If you live in the center of the city, you use your car less. So we have these archetypes of how much you use your car. And then in these archetypes, when I reduce your tendency to take the passenger car because I made it less attractive to take it because several factors, you will move towards your next best alternative, which could be taking the bus, taking the train, taking the bicycle, which is very common in Denmark, and so forth. So we would see an expected increase in bike kilometers, bus passengers, and so forth. Also a general decrease in kilometers ridden. And here we come back to the activity. Here's where I can talk with the mobility department, because I say, if we do this, I would expect a 5% increase in passengers by buses. And they have similar models who would say somewhat the same. And then we're in agreement about what we're really talking about. Once we have these actions, we present our results as the sole reduction in, let's say, 2030. And we usually present these results as a one-pager in PowerPoint format and add these to many different graphs. We usually use waterfall graphs. But this is where I believe we are starting to do something new with the climate forecast tool. Because we've added all of our actions into this interactive climate forecast tool, where we have all our actions targeted towards scope 1 and 2 in Aarhus municipality as a territory. And I can say that a thing that has happened for us in the recent years is that we wanted to be climate neutral in 2030 using a carbon capture storage facility, but this was not an possibility. So we had to remove this action. As you can see outside here, I removed it. But another thing could be looking at other emissions outside here. So let's say we might not get this zero emission zone I was talking about. This could also be removed. So we want to make all of our actions something that the politicians can see here. And what we're presenting mostly is the annual impact over here, which is how much is CO2 reduced in a target year, but also how much cumulative effect is the CO2 reduced by. And to return to climate budgeting, we also present what is the expected cost of this in our currency. We want to keep on adding this. We want to see that currently we're only using scope 1 and 2 emissions as a territory on our way to also be doing this as a company. We do not have a comprehensive analysis on our scope 3 analysis as either a territory or a company. Lastly, I also wanted to give a bit of a contact card for both myself and Aarhus municipality for the later part of this thing. So I work in Aarhus Municipality's technical and environmental department in mostly climate and other modeling parts and emission calculations. Feel free to text me on email, add me on LinkedIn if you have any questions or want to see how our CATS tool is actually working. Aarhus municipality, in a greater sense, has been doing different parts of climate budgeting for 2 to 3 years. And we really have done a lot of work in energy transition, both in the real world, where we're actually doing some cool projects, and in calculations. Where we want to be better is in the agricultural sector, both regarding what can we do and how do we calculate this better. As Olena teased earlier, the next physical attendees will be in Turku in the beginning of September, where I will not be attending, but some of my good colleagues from Aarhus who are working within the same climate team will most likely be attending. Thank you for your attention.
Thank you, Mats. Sounds great. Oh, pity you're not coming to Turku, but it's still a few months away, so let's see how it goes. We have now 3 more presentations from our piloting cities of the Climate Forecast Project. So we're really looking forward to sharing the specific experiences they have about building the data inventory and working towards meaningful climate actions in specific sectors that they would be presenting. And the first one would be our partner city Östersund that will handle the case of the mobility actions, if I remember correctly. So Rasmus, welcome.
My name is Rasmus Vermum. I'm a project leader here in the municipality of Östersund. Daily, I work with action modeling and effect assessment, as well as emission inventorying. So just a quick view of the settings. So Östersund is a city located in the middle of Sweden. We're the only city in the region of Jämtland, which covers around 12% of Sweden. We're the 3rd largest county when counting area and the 2nd smallest when counting population. And the city of Östersund inhabits around 65,000 residents. So in Östersund, much like other municipalities, most of the emissions can be tracked to the transport sector. So around 48% of the city's territorial emissions stem from transport, and 63% of those emissions stem from the passenger car fleet. So this means that around a third of all the territorial emissions comes from the passenger car fleet. And it's therefore important that the municipality tries to reduce these emissions, and at the same time the municipality identifies a lack of direct control to reduce them. But there are some ways that the emissions can be impacted, like either through hard infrastructure, such as building walking paths or bicycle lanes, or through soft regulations, such as speed reduction or parking regulation. And we chose to focus on the latter for this presentation, namely parking fee regulation. So why a parking measure? Well, we own most of the parkings in the city center, and therefore control and have access to the data about the parking usage. And since access to good, reliable data is usually a limit when analyzing, we thought that parking assessment was promising. So all in all, we have around 2,000 parking spaces, and there's around 900,000 parking transactions per year. And the parking data includes the start and stop time, the parking costs, the vehicle identification, so the registration number of the vehicle, as well as which specific zone was this parking done in. So in Östersund, we have, I think it's 7 different zones with 3 different price ranges. And we noticed that we could supplement the vehicle registration number with vehicle data from the Swedish Transport Agency, which gave us the registration address for said vehicle. So, what could we do with this data? Well, we had a parking tax or parking fee change during April of 2025. And our access to the data opened up for a possibility for us to conclude an analysis of the price elasticity of the parkings. In other words, what does a change in price mean to the change in parking demand? And through the registration address, we could do a spatial distribution analysis to assess the spread of the incoming traffic, like where in the city are the parkers coming from, as well as we could assess the average distance for each traveler in each parking made. So what we did was, let me just get my laser here. We defined different usage patterns and categorized two different groups where we had workers and normal parkers, where workers were parkings over 5 hours on weekdays and the normal parkers constituted the rest. So we did the categorization to have the possibility to assess the effect of a specific parking policy on differing groups. So we wanted to assess the price elasticity both in terms of like amounts of parking as well as the mean parking time for both groups. And we did this to somehow assess both the change in parking behavior, which is how long do you park when you park, as well as to assess the change in travel behavior, which is, well, how often do you take that trip, which results in a parking. And we actually did the analysis for each of the parking zones as well as a total for the entire parking area. And through this, we could assess how much each group would change their travel and parking behavior through a given change in price for the specific parking policy. And we also did an analysis of the geographical spread of the traffic using the registration address. So we knew the like endpoint area, which is the parking zone that you saw earlier, and we did some mapping to sort out and assess exactly what type of distance that zone would mean in relation to the starting point. And we estimated or assumed that the point of origin for the travel that resulted in the parking were likely to be the registration address of said vehicle. Now, through the analysis, we could assess the mean kilometers driven per parking and thereby estimating the total traffic load connected to the municipal parking spaces. So basically, I did this very, very short picture yesterday, but basically, like using the assessed mean distance for each parking, we could assess the total traffic load from the municipal parking system. And when combining the price elasticity in relation to a specific parking policy, we could say, like if said policy increases price with X, demand will fall by Y for the differing groups, both for in perspective to parking and travel behavior. And we can thereby get out an effect, a reduction in traffic given in kilometers. But that would also the policy would also like result in an increase in operating net, as the remaining parkers would pay more than the monetary loss of the reduced traffic. So we could thereby like express the cost effectiveness of the action and later the cost benefit of that said specific parking policy. And through the CADS tool presented we did it towards the technical management, which took it forward towards the decision makers, but I will mention that later. And since we could break the data down to kilometers driven, we could enter it into our CADS tool, as our emission inventory is built upon like traffic load per energy carrier for the car fleet. And we could we could, since we have like matching data sets in the detail level, we could through the tool visualize our assessment of said parking policy and how it would affect our territorial emissions as well as our municipal budget. So just like the summarizing the quick results here, the quick results were that workers don't really change the length of their parking, but instead they decide to change how often they travel to the parking spaces, which is rather logical, because if you travel for work, then you're really like framed by how long you work, so you can't really pass on that. So they just try to travel other ways, perhaps. And the normal parkers showed quite the opposite behavior. They don't change how often they travel, but they do change how long they park. So the traffic load reduction that we've identified is more so solely connected to the commuters, not so much the normal parkings. And there was a long time since I did this analysis. It was like last summer. But I think it was something-ish like the reduction for a normal parker, which had like a mean time for an hour. They decreased their time spent in a parking space by 12 seconds for that hour, given a 20% increase in price. So why are these results important? Well, we can communicate to the businesses in the city center that parking fee regulation has little impact on their businesses, since it doesn't impact how often people go to the city center and purchase stuff or do whatever. And the time reduction is so little that it hardly will impact their business needs, or whatever the term is. And we could also show for decision maker that an action targeted to like reducing kilometers driven in this case, that doesn't necessarily carry a cost. This specific test that we did, we just did a rough price increase for the total parking scheme, and it showed an increase of about 220,000 euros annually for the municipal budget. And as I mentioned earlier, we pitched the assessment to the technical department, who appreciated the analysis and the result, and then took it forward towards the decision makers in the specific technical board, I think the term is. But the decision makers didn't really want to mess around in the parking debate now before the election this autumn. So we've kind of had a lid on the discussion so far. But there's some things that I do wanna lift up with this type of like analysis. I really wanna raise like a finger of concern, as there are two major holes in our methodology. Probably more, but these are the ones that we really wanna like talk about, have a discussion about. So we can only see what we measure. We can't say that the traffic that was lost during the fee increase in April 2025 hasn't just simply moved to the outer areas of the parking zones, which would mean that we don't have this reduction in kilometers driven. It's just a small reduction because they choose to park outside the parking fee borders, so to say. And since we have no data, like how has the parkings gone outside this type of area before and after the price change, we can't really say we've lost all this traffic. This traffic has now had a modal shift, or whatever you wanna call it. And our assessment has been like concluded in the way that assumes the price elasticity to be linear, which really isn't the case since the parking price doesn't exist in a vacuum. It's always like evaluated well relative to like other alternatives such as public transport and cycling. So this means that we will have some sort of thresholds for the parking prices somewhere, which will push the parking cost over the cost of public transportation and perceived cost of cycling, which would like push demand down even further over a specific price range. So, like, if we want to take in all the effects of our action, we ought to assess how public transport was affected by the change in parking prices, and how was the amount of active transport affected through this policy. And like, even if you can't make those assessments, it doesn't mean that there's no need to make the assessment of the parkings. It's just that it's important to carry on that the policy doesn't impact like the parking situation in a vacuum. So there's like you still have to have that in your backpack, that there's stuff that you haven't analyzed, and you need to have some sort of a discussion about that, even though you can't really portray or talk about the data of it. And it just means that the policy it will impact other transportation modes, and its effect will be rather relative to the transport alternatives. And I think that's all I had to say about parkings so far. So I just wanted to throw up my contact card here as well. As I said earlier, I do a lot of work in like action modeling, effect estimation, emission modeling. I've been working in this project for climate budgeting specifically since 2024, and I will be joining in Turku during the 1st and 2nd of September. So I hope I will see some of you there.
Thank you, Rasmus. This was great. If you have any questions, please stay around until our moderated discussions at the end, so you can ask them directly from Rasmus or write them in the chat, which is also possible. Meanwhile, we go to our next speaker. We will have a presentation from the city of Riga next. And Krista, please just go ahead if you're with us and share your screen. I will not be intervening in between anymore with my presentation. So yeah.
Okay. Hello. Good morning, everyone. Very nice to meet you all, and thank you for the invitation. So in my talk, I will have a slightly, let's say, a broader picture, just because I'm working as a coordinator for Riga's participation in the Net Zero Cities mission. So sometimes I do not have a very detailed insight in the project level, let's say, calculations and estimations. So I think that will also offer a nice comparison between different approaches and different cities. But as we are meeting the last day of March, we thought that we could tell about the relevance and integration of solar energy in Riga's energy system, because also March was the first month when in our region we have noticed the really kind of role and also prospects of use of solar energy and how it impacts the overall prices of electricity, and also what opportunities and benefits there are that we can draw from it. So just a quick reference to our goals. As you may already have heard from my colleague Inga, who is the manager of this project, Riga has a high ambition towards, let's say, reducing greenhouse gas emissions till in this decade. And if we look on the left, the image shows that the sharpest reductions are estimated in the transport, but also in the electricity field, which is the darker blue area. So then we thought, let's look into this electricity field and the prospects for reducing emissions right there. But we must also know that the climate contract ambition is significantly higher than currently our development program and also investment plan estimate. But again, municipality and budgeting. When we look at the emissions by sector, we see that the role of the emissions from the municipal infrastructure is actually small. It's around 2%. And that makes that's significant when we think about the possibility to reduce the emissions as a whole just by investments in municipal infrastructure. So that in that case, it's not something that we can achieve with the municipal budget itself. And of course, collaboration is important, but also broader policies in this case. Yeah, and I would like to talk about actions that are related to integration of renewable energy sources for electricity generation, because this decarbonization of electricity to supply is expected to contribute most in the energy sector. But that, again, because of Riga's central role as the capital city, those measures are related to the National Energy and Climate Plan and also Riga's district heating strategy that is still under development. Just a few slides about Riga's challenges. You see these larger orange circles around Riga, and they show the use of natural gas, our main fossil resource that's imported, that is used for cogeneration of both heat and also electricity. And and somehow concentrated on Riga, and of course it serves the national energy system, but the location is very significant. And in this map, you also don't see the more renewables-based hydro plants, but it just shows that actually Riga is the most fossil-intensive in terms of power production, whereas the Latvian average is actually much lower in terms of fossil fuel use. Similar but more zoomed in situation when we look at district heating also separately, because electrification, of course, is one of the goals for district heating development. But here also the same objects that are related to this power system are also responsible for the highest share of Riga's emissions in the district heating sector. Yeah. But just now to the solution. Solar energy has not made a large contribution previously. And in the image on the left, you can see that the red part shows that its relevance is visible only from, let's say, 22, 23, 24. And now the development is quite fast, but still there are some limits. And on the national scale, hydropower contributes definitely most to the share of renewable energy. But still, despite the somehow very central fossil energy production, Riga has a very high place within EU in terms of the share of renewables. If we count in biomass, then it's the fourth place. But renewable electricity only in final consumption, that's the seventh place in the EU. Still, I think it's rather good. And now about somehow the measures. Of course, Riga as a whole, to decrease the emissions in the electricity sector, it's important to look at the, let's say, also households and commercial sector. And then in the last, say, few years, the increase has been quite substantial. It's from 10 megawatt to 64 megawatts at the end of 25, just installed PV capacity, but it's still quite, let's say, small compared to the whole energy system, of course. And in this growth, which is not directly impacted by the municipal strategy, there was a major impact of EU and ETS funding that has provided mostly grants-based support to commercial actors and households who have, let's say, developed those rooftop solar projects, and they have a very direct impact. It started with the micro generators and mostly owned by natural persons, but now the development is more visible in, let's say, solar stations, larger ones, and other stakeholders. On the municipality level, there was also a very interesting project implemented just last year, because before that, the total amount of rooftop solar was still, again, small. And now it's above 600 kilowatts. There is, of course, room for growth, but the funding that came, it came actually from energy savings that were somehow then transferred monetarily for also investments of rooftop solars. And we have more projects in the pipeline, and Riga will also apply for support from modernization funds programs. So then this is a very somehow active field of development. But again, when we look at the impact on the whole emission inventory, that's a very small share. And finally, just also another project that has a quite interesting relation to this development of a renewables-based power system in Latvia, and also municipal investments, not directly, but actually investments and budgeting managed by Riga's district heating company. So it was a very, again, interesting project that started operating this year. And now it is the largest electric boiler, I think, in Latvia, maybe also in the Baltic states, that somehow can react very quickly to the changes in the electricity system. And its economic rationale was not only to replace fossil gas for water heating, but also to provide balancing services to the whole power system. And it has started operating very recently, and it will be also a part of regulatory sandboxes so that they can experiment with different price regimes and also operation regimes. And this somehow one of Riga's main stations in the district heating system. So these were somehow three types of solar electricity related developments, both on the city scale, then municipality scale, and this one already that extends to the electrification efforts of the district heating as one of the main consumption sectors for renewable electricity. But then again, if we look at this GHG inventory and to the values of the last years, because we still don't have the values for the very last year, we do not see any direct impacts. But that's because the methodology that we use, it does not really reflect those huge, large-scale changes in Latvia's power system. And one reason is that for this consumed energy or electricity that somehow delivered through the distribution system, there is one constant emission factor applied, and it's been so for years. So in a way, this factor, it does not reflect the somehow temporally correlated changes in the electricity system. So for this is an interesting methodology question, and of course also shows the differences in approaches between, let's say, top-down and bottom-up emission inventories for cities, companies, and projects. Okay, and now the final conclusions. We see, especially in a city as Riga, which is the capital and also has this somehow very central role in whole energy and power system of Latvia, that we see that local action is integrated in broader energy markets and policy conditions. So power system as such is somehow not local, but non-local, not only nationally, but also regionally through Nord Pool prices and let's say synchronization with the European grid. And that has very direct financial impacts for investment planning. Then we also know that direct municipal investments through the, let's say, city budget in the energy field will still tackle very small part of energy emissions. And that makes collaboration and these policy approaches even more important. And finally, what we also see as as prospect for future work is that there are these methodological questions about GHG intensity of electricity consumption, because we would, of course, like to somehow stress and promote the use also from grid imported electricity that has higher share of renewables. But how to integrate those temporal and geographic approaches, let's say, for different types of emission inventories, that's still one of the topics that we are working on together with our colleagues at Riga Energy Agency and also other institutions. So thank you again, and we look forward to working with you and just exchanging opinions and experiences also further on. So, yeah.
Thank you, Krista. Sounds very interesting. Please direct the questions into the chat or for the discussion group afterwards. We go ahead with our last city presentation from Bytom. So, Robert, I welcome you to the stage, and you can share your presentation and begin.
Thank you. My name is Robert Białas. I'm working in Department of Environmental Engineering in the city of Bytom. And today I would like the presentation a short case study about carbon assets in the city. We started with a simple question: what is the real carbon value stored in the city's ecosystems, and which category of greenery absorb the most CO2? And the second question was, how can the value shape planning, investment, and protection decision? So using satellite data, field validation, and a practical policy lens, we translated green space into something city managers can actually work with, and urban carbon assets. Why does this matter? Because many post-industrial cities are richer in carbon assets than they realize. The problem is not a lack of greenery alone. The problem is that these assets are rarely visible in the language of planning or budgeting or land use decisions. In practice, cities often manage roads, loads, and investment very precisely, but they manage carbon stock only by accident. In Bytom, we wanted to make that invisible layer visible. What method we use and what was the objective was broader than a descriptive inventory of green areas. We wanted a city-scale assessment that answers three operational questions. First, what exactly do we have? Second, which ecosystems works as fast absorbs and which work as long-term stores? And third, what should the city do differently because of that knowledge? Audit we have done should change how land is valued, how risks are understood, and how climate priorities are set across departments. And these are the challenges ahead of us: how to integrate carbon assets and climate adaptation into the language of investment planning, urban change, and the rules that shape urban space. At this stage, the issue is not about making financial decisions, but about creating a framework for spatial planning, environmental policy, and investment policy. And as so often happens, the answer is not black and white, especially when politicians must ultimately make the decisions. The method is important because credibility matters. We did not rely on a single layer or a vegetation index. Instead, the approach links orbital data with classification and then with what really matters on the ground: soil conditions and biomass. In other words, we move from space to soil. That is crucial in post-industrial terrain where the visible green surface does not always tell the full story. Some places looks modest but store enormous carbon below ground. The method helps cities avoid the very common mistake of equating green looking with high value. The methodology was divided for 4 steps. We used the Copernicus system, Sentinel-1, Sentinel-2, and so on. And next, we use machine learning algorithm classified every pixel into one of 15 land cover categories. And in step 3, we validated the results on the ground. And we combined soil carbon and biomass into a total carbon balance for the whole city. What is important, this methodology is repeatable. We can update it every few years, making it a monitoring tool, not just one-off audit. This is a headline number, 4.84 million tons of CO2 stored in the ecosystem of Bytom. This is a combination of soil carbon and biomass carbon multiplied by the standard factor of 3.67 to convert from carbon to CO2. Think of it as the balance sheet value of a city's natural carbon estate. But this number must be interpreted carefully. Stored carbon has accumulated over centuries. If we destroy a wetland or a mature forest, the carbon re-enters the atmosphere in years, not centuries. So the first lesson is protect what we have. The decisive layer is soil. Wetlands and reed beds are exceptional because they combine vegetation with carbon-rich, water-influenced soil. That is why the stock values are so high per hectare. As you see, 1.387 ton CO2 per hectare. Deciduous forests, on the other hand, are the biggest warehouse in area terms, so they carry a huge share of the city-wide stock. Next, urbanized land performs poorly in comparison. The policy lesson is almost brutal in its simplicity. If you damage soil, you damage the carbon system. And this leads us to a broader planning question. How do we reconcile the pressure for urban growth with the protection of biodiversity and environmental quality? Urban development and greener protection are not inherently contradictory. Conflict starts when development is understood only as taking new land. In reality, forests, meadows, wetlands, and unmanaged green spaces are part of the city's infrastructure. They cool the city, retain water, sustain biodiversity, and store carbon. Stock tell us what the city already has. Flow tell us how fast it can keep absorbing carbon. Here, the most dynamic category is young forest plantation. This is not surprising. Young systems grow quickly and capture new carbon at a higher rate, 70 and almost 18 tons per hectare per year. Mature deciduous forests are less spectacular, but they provide a stable sequestration backbone, almost 8 tons per hectare. And because they cover the largest area in Bytom, they account for 60% of total annual absorption. manage urban green and parks performs lower, yet it still improves the annual balance, 4 tons per hectare. Total annual sequestration for the whole city is approximately 23,500 tons per thousands of CO2 per year. The practical message is clear. It's, if a city wants visible gains before 2030, planting and establishing young woodland is one of the fastest levers available, provided the soil is protected as well. The audit becomes useful when it's change action. Our first action is simple: protect the highest carbon areas first. Forests matter because of scale. Wetlands matter because of intensity. And post-industrial habitats matter because they are often misunderstood or undervalued. In planning practice, these areas should move from the margin to the center of discussion. The question is, how do we protect them? By including them in local spatial development plans as priority ecological zones, by prohibiting draining, deep soil disturbance, or construction of these areas, and by educating decision makers that these unused lands are actually the city's most valuable climate assets. 3 key conclusions from Bytom experiences. First, sequestration is not the same as climate neutrality. The fact that our green spaces absorb 23,000 tons a year does not mean we can emit 23,000 extra tons. Second, soil is the central issue. Trees are visible, but the largest and most durable climate value often sits below them. Third, this leads directly to emissions budgeting. If natural assets are finite and fragile, then a city must control what it emits at source. Green infrastructure can help, but the direction must be reduction, not offsetting. For city managers, the real test is institutional use. The audit should not stay inside the environmental department. It needs to enter planning, finance, and investment workflows. In land use planning, carbon-rich areas should alter what is seen as suitable or unsuitable development. In climate policy, the audit should support an emissions budget grounded in real ecological limits. And in investment, it should function as an early warning system. Don't create one project by destroying another asset. This is where analytical work becomes governance. So we close with an invitation. We see this work as part of a broader learning process, not as a finished local product. Bytom is interested in partners who want to connect climate accounting with planning, budgeting, and investment decisions. We can share our experience on carbon sinks, local energy transition with municipal administration perspective, especially in this part of Europe. And we are eagerly interested in learning from your cases. My contact is on screen. Please reach out. Thank you.
Thank you, Robert. This was a nice conclusion for the city presentations. I have still a short presentation about the matchmaking, which we will very quickly do before going into the breakout room discussions. So as you have seen now on Robert's slide, but also on the other presenters, we have kindly asked all of our city partners to include digital contact cards, and I'm going to explain you why. So as I mentioned in the beginning, the purpose of this course is to provide you with insights into some findings from the piloting that we have been doing in the project, to give some broader methodologies from renowned experts and organizations that are working on the subject of climate budgeting and various stages and steps. But we also want to give you a possibility to exchange and not just listen, and maybe not only exchange during these scheduled events, which are not always scheduled for your best convenience either, because we all have working and other life limitations. So we have conducted this surveying at one of the previous modules, what would be the methods of exchange that participants would be interested in. Of course, these are not super comprehensive because those were answered by people who were present at that session, but I think it gives quite a good representation of what is in general demand, so to speak. And the highest voted offers were the moderated discussions that we will move to, so where people can freely go through and discuss and question and reflect upon the things that they have learned at the specific event. But we also try to do the second option now, which got the most votes as well, which was a peer matching with other cities and exchange. We will help you a little bit with organizing these, because of course you can do it the old school type. Just find the presenter from today, reach out to them via email or LinkedIn and ask questions that you might have. But we will try to introduce a little bit more structured method, which we have called digital contact cards. And the purpose of this exercise is basically to give a possibility of exchange outside the scheduled events of the training course, because it has its limitations, like I mentioned. So you've seen today the contacts from our speakers. They have indicated their specializations, the areas in which they would like to exchange, the areas in which their cities have expertise or they have expertise. So this is basically a reflection on the partner side from the climate forecast, but we also invite you to submit your own digital contact cards to us so that we can match you with our cities in the project or other cities that would fill in this form as well. So we have made it in the Google document form. I hope it works. Maria will drop the link in the chat now, which you could go and fill in. There is only one, I think, mandatory question. I want to twin with a city that the others are good to know. So the more information you provide, the more likely it is that we will find a match for you. And we also don't have a deadline for this exercise. So if you can decide about it and think about it already now, the sooner you make it, the quicker you'll be able to exchange with peers and with cities that we would be able to match you with. If it will take a bit of time, it's still possible to arrange this until the end of this course. We will, as I mentioned, we will have a next module on 7th of May. Let's see how many replies we get if we can integrate it. At least we will still ask the speakers to include their digital cards at the next module. But one big important notion in here is that during the physical event, the 5th module that will take place in person, to which you all are invited and any new participants could be absorbed as well. We will try to make a room and a possibility for this exchange also at the in-person meeting. So this is basically it for now. As I mentioned, please just be in touch with us and subscribe for the training in general so we can inform you about the details of the Turku event, but at least you know the dates now and yeah, and the place as well. So it should make it a little bit more ahead, advance warning, so that people can make themselves available. Here is an example of a digital context card, how it could look like in a very concise view. Please don't contact Matti, he doesn't really exist, but this is an example of what we're looking for and what people can exchange on based on the questions that we have been coming up during the previous modules as well from different participants. So this is what we're trying to make. And also in the form, there's a question about interest in Turku event. It's indicative, it's not a registration itself. So we will be just feeling the ground of how many people would be able to come and would be interested in doing that exchange.